Over in the lab, we're going to check out how Pliant automation can really help people troubleshoot their networks. On the top left, I have my NMS, and that's where the alert will appear. On the bottom left and right is a login to the same router. On the left, I'm going to start an ICMP trace to a particular IP address. And on the right, I'm going to configure a route to a bad host or an invalid route such that connectivity to that particular IP address will stop. We'll see the ICMP echoes starting on the left, and on the right now when I hit enter, they've stopped. Now in a couple seconds, we'll see the NMS alert pop that actually something has happened. And then that will actually trigger the automation piece. On the top right is my ServiceNow account. So what I expect to happen here is that I'm going to actually get an incident alert, and I'm going to be able to click into that incident alert and see what has happened to actually cause the incident. So my alert has come up now, and if I click in it, we can see in the description field that the line that has changed is that IP route 4221. The way that route actually got into ServiceNow is that we ran a routine that compared the running configuration of the router to the goal configuration stored in our GitHub repository. And the difference was that one route. Now I'm going to bring up the front end for Pliant. Pliant drove the automation you saw where we were able to diff the config from a running config to a stored gold config. This dashboard shows you the number of workflows that have been executed in the last 24 hours, the number of executions that have happened in the last 5 minutes, and just for informational sake, it gives you the last 5 successful runs and the last 5 failed runs. If I click on a log entry, it'll actually bring up details about that particular workflow's run. This was the workflow that actually executed the diff and populated the ticket in ServiceNow. We can see that it was executed by a job called demo, the time started, the time finished. We get a URI to the actual workflow itself, a UUID, so you can go back and check on this by log number or index it. And lastly, the bottom third of this is the output of the job itself. It stores about 3 days worth of logs. And then we expect our customers will ship this off via syslog to storage like Splunk or wherever they do their governance. Each of these is provided as evidence that the job ran and what the output of that job was. So in this case, we see the diff. Now let's take a look at the workflow that actually did the work. Pliant is a low-code, no-code UI that allows us to drag and drop blocks to build out this automation. The top block there is the block that helps sync the alerts from an NMS to our instance of ServiceNow. Then we loop through the alerts as you see a for each loop. And lastly, we do a little bit of cleanup. So here's where we do the diff between the running config and our gold config in GitHub. We scroll down to our last really important block, which was the block that helped us interact with ServiceNow. The great thing about Pliant is it's a bunch of drag and drop blocks. So I just pulled this particular block over. I said I want to update this incident. And then I was able to take the values that were up above and actually pull them in and be able to provide that as information that shows up in ServiceNow. To sum things up, Pliant is an IT process automation platform that utilizes a low-code, no-code UI to bring you automation throughout your infrastructure. We support vendors like A10. We support the use of Ansible playbooks. We also support end-user monitoring with Appneta, Arista, Cisco, ticketing systems like ConnectWise and ServiceNow, load balancers, A10 and F5, and actually you can even bring your IPAM solutions such as Infoblox, your server provisioning workflows from Jenkins, and wrap it all into a single platform that uses low-code, no-code blocks to deliver IT process automation.